Welcome to today's training. Today's training is about the floating point numbers. And in today's training, we will learn something about the float point data transmission, data comparison, and the athletic operations. And first, let's see some tips about the LX3V series for floating point data. As I referred, as I said in the first day training, not all LX3V support the float point instructions and can do the float point operations. And the first, if the PLC is the 1S instruction, it doesn't support any float point operations. And for some operation instructions for LX2N instruction, it also doesn't support. Let's see it. In this instructions list, we can find it the plot floating for 1S instructions PLC. It doesn't support any instructions. And if for 2N PLC, 2N instruction PLC, some complicated arithmetic operate instruction is not available also. So if you have some required for comprehensive float point instruction, it's more recommended to use the LX 5 ways. Okay, the first we are going to the data transmission instructions. The first instruction is FLT. This instruction is convert the integer to binary float point number. So it has just two parameters. The first is the integer value, and the second parameter is the register, which saves the binary float point number. As we can see in this instruction, and I will show you in the real program. This is the program FLT instruction. For now, if I didn't trigger M1, D12, D20 is 0 now. So let me trigger it. M1 is on. So you can see I make it bigger. As you can see now, D20 is a negative 1.23 and E02. This is the in our PLC, all the floating point number it will be showed in scientific note. In a scientific notation. So there is not anything wrong with this presentation. It just shows the value, the data format is the float point number. And if I change the value, it also convert 165 to a float point number. Okay, let's move on. If we have a single position real number and we want to convert it to the signed BIN 32-bit data, so we need to use the DINT instructions. It also have two parameters. The first, we save the single position real number, and the second parameters, we save the converted data. And there are also some related special registers. If the operation result is 0, so the SM153 will be on. It's the 0 flag. And if the number is minus, the value is the minimum value of a 32-bit real number, and the borrow flag will be turned on. And the third special register is SM151. It's a carry flag. So when the value becomes a maximum value of 32-bit real number, and the carry flag turns on. Let me show you in the program. Okay, let's see it. If the value of D0 is 3.478, the SM152 is on now. And if I change the value, change it to 0, and the 0 flag will be on. And if I change the value of D1 as with a very large number. You can see if the value is out of the range, so the carry flag will be on, and the value of register result will have some problem. You can see it's not the value I input, so it's out of the range. It's the same program, shows the different value, the different register triggered. And if we want to transmission the single precision real data, usually in LX5 we use DEMOV, just like the normal, the common instruction MOV. It just moved the value to one register to another one. But in LX3V, this instruction is not available, and I will show you how to transmission the real data in LX3V later. This is a very easy instruction, so it's no need to represent in a real demo. Now we're going to the second part, is the data comparison. The first instruction is DECMP instruction. It's used to compare two data and output their larger, small, or consistent result with the 3-bit device. It's a consequent 3 relay address. And as we can see it, if the first parameter is the the first two parameters is for the value we need to compare, and the third is for the specific relay, which to show the result. And if S1 is bigger than S2, so the D register will be on. And if this two value is equal, the D plus 1 register will be on. And if the S1 is less than S2, so the D S2 register will be on. And just remember the float point numbers occupied two consecutive PLC addresses. So let me show you in the CMP. In this, if we set D30 is 1.4556 and R30 is 2356 and use the DECMP instruction. So the M2 will be on because D30 is less than R30. So if this value is equal, the M1 will be on and the M11 will be on and the M12 will be off. Let's move to the DEJCP. It's the brand comparison. It's a little like the instruction we showed yesterday. It's DHSJ, the zone comparison for high-speed counter. So it's the same. The first two parameters is to set the range, the brand weight, and the third parameter is the value we need to comparison. And the last register is for to output the comparison result. And if the S3 is less than the S1, so the D register will be on. And if the S3 is equal or bigger than S1, but it also bigger or less than the S2, so D at 1 register's address will be on. And if the S3 is bigger than S2, so the D at 2 register will be on. Let me show you in this demo. So as it showed, the number we need to compare is 1.5 now, and we set the range is from 10 to 100. So it's when the value D50 is less than the minimum value of the range, here is 10. So the first register M40 will be on. And if I change the number, the value D12, D50 to 15. And you can see now M41 is on. And if I set D50 is to 150, and now you can see the M42 is on. Just the same function like HSCZ I mentioned yesterday. In this presentation, I also attached this GIF picture. And for the float single position precision real number, it also has the content comparison instructions. It's the same used for like the integer registers in integer value. So just a different is the instruction here is LDE. For example, if it's LDE equal, so it means S1 equal to S2. This contact is on, otherwise it's off. Like this demonstration. As you can see, this instruction, it just showed E, not LDE, the LDE in here. And the value of D10 is 1.23, so it was not equal to 2.56. So here the Y11 is on, and it also less than 2.56. So Y12 also is on. So when I change the value of D10, here we remember to choose the float data type. And if I set 2.56, and you can see it's equaled. So here is off, Y11 is off. And here the Y10 now is on because it's equal now. So you can use this instruction for some requirement needs to compare the float value and to trigger some instructions. Now let's move to the arithmetic operations. Here I just showed the 4 instructions. The addition operation instruction, DEADD, and the subtraction operation, DESUB, and the DEMUL to multiplication of operation, and the DEDIV for division operation. This instruction is also available in LX3V and LX5V. So if we want to transfer a real floating number to one register to another one, you can also use the DEADD. Just add a 0 value, so it will convert D0 to D4. Because there, I just mentioned there is no DEMOV instruction in LX3V. So these four instructions also it all have three parameters. It's for edit data, and then another edit data, and the last register to save the result. As you can see it in this picture, the result, this addition operator result is 64.4. So the value was saved in the D4. For the DESUB subtraction operation, the first is the subtracted data, and the second is the subtract data. So the third also the result. It's also the same as the addition operation. So the value of D2 will be negative 62. About the multiplication operation, DEMUL, it also can be showed here. The D4 is the result, 75.84. And for the division operation, DEDIV, the first parameter is for the divided data, and the second is the division operation data, and the third also the result. So when so you can see here, D2 is the value is 63.2 divided by 1.2. The result 52.66 were saved in D4 here. Okay, this is today's training. Do you have any questions? Because today's training is a little short than before, so we can have time to discuss here now. And I just one thing to mention is the still is for LX3V. Some instruction is not available, and you can check this table. this instructions list. It shows the different type PLC. The some instruction is not available. For here, as FLT is also available for LX3V1S instruction. I just mentioned a part of the whole floating point instruction, and all these instructions is available in LX5V. Okay, so if you have any other questions, you can also leave your message in our group, training group. Okay, so after this training, I will leave the after training exercise. Just remember, if you didn't submit for the exercise for more than 3 times, it may be you have no permission to attend the final exam. So just notice that. Just pay attention to that. And it's okay to submit later, but it's better than you didn't submit it. Okay, so today's training is finished, and thanks for your attend. And we will have 5 days holidays in China, so we will continue our training in the next Monday. So I think you have a lot of time to prepare the after class exercise for 5 days. Okay, thank you for everyone. Goodbye.
Recording stopped.